On problem 31, we're supposed to factor the given polynomial. Anytime you factor any polynomial, you always want to look for a greatest common factor first. And so that's how we're going to approach this one. We're going to look at each term and see what each term is divisible by. Look at numbers first and then look at variables. In this case, each number is divisible by 4. Then we'll move on to variables. First we'll look at the m's. Each term has at least one m that we can factor out. Each term has at least two p's, or p squared, that we can factor out. And each term has at least r squared that we can factor out. So 4m, p squared, r squared is our greatest common factor. We'll write that in front of our parentheses, and then write inside the parentheses what's left after we divide each term by our greatest common factor. And so when we divide the first term by that, we end up with 2mp. The r's cancel out. 2 comes from 8 divided by 4. Dividing the next term by our greatest common factor leaves behind just a p. And then dividing the last term by our greatest common factor leaves behind a 1, because the last term matches our greatest common factor exactly. And so here's what our final answer looks like. On problem 32, we're asked to do the same thing. We want to factor this polynomial, and so we want to first take a look at if there's any greatest common factors. Looking at each term, each coefficient is divisible by 5. They don't all have a's in the term, so we can't factor out any a's. But they do all have b's. We can factor out b cubed. And they all have c's. We can factor out c squared. We're basically looking at the letters that they have in common and focusing on the smallest exponent from each letter. We'll write 5b to the third c squared out front, where our greatest common factor goes. And then in parentheses, we'll write what we get after we divide each term by that greatest common factor. In the first term, negative 5 divided by 5 gives us negative 1. We'll still have the a squared because none of the a's canceled out. We'll be left with b squared and c squared. In the next term, negative 10 divided by 5 gives us negative 2. The b to the thirds cancel out, and we'll be left with 1c. And then in the last term, 25 divided by 5 gives us 5. b to the thirds cancel out, and c squareds cancel out. And so there's our final answer. Problem 33, we're asked to factor the given polynomial. In this case, all 4 terms don't have a greatest common factor, but if we try factoring by grouping, then we may find that each individual group has a greatest common factor. So we'll split this into 2 groups. First we'll look at the first group, 6xy plus 12x, and see if those 2 terms have a greatest common factor, and they do. Both numbers are divisible by 6, and they both have an x. So when we factor out 6x, that leaves us with y plus 2. Now we'll look at the second group. Both of those numbers are divisible by negative 5. And so when we divide each term by negative 5, we're left with y plus 2. When you factor by grouping, if that type of method is appropriate for that polynomial, then what you end up with in the parentheses should match. And so we're essentially finding the greatest common factor again. In this case, both terms have a y plus 2. And so we'll factor that out to the front. And then when we divide that out, that leaves us with 6x and minus 5. And that's our final answer. On problem 34, some of you may have a typo on your sheet. In place of the x next to the 3, there is supposed to be a w. And again, all 4 of these terms don't have a greatest common factor, but if we split it into 2 groups, then we should be able to factor by grouping. So the first 2 terms both have a w, so we can factor out a w, leaving us with d plus 3. The second 2 terms are both divisible by negative 4, leaving us with d plus 3. We'll factor d plus 3 out to the front, and that'll leave us with w minus 4 for our second factor.